All right, follow up to that last video because it finished running. Uh, what happened is it crashed. It ran out of memory. There was some mistake in there. There was a couple mistakes in there actually. When I went back, loaded it in, and did things line by line, I started to find some errors. And the biggest one is that, as it turns out, merge doesn't behave nicely with pipes. So let me zoom in on the big change I made, besides the typo, which you might have caught. Now we're just, instead of merging through a series of pipes, we're creating out df as merge df and mean in, then it's merge itself and median out, and it's merge itself and min in, and so on and so forth. It's a kind of an ugly way to do it, but it's getting the job done. So when I run that all, file is too big, 150 megabyte file. Okay, so that's why it crashed. It is making a ton of stuff. Let's look at the head of SD out. It all seems okay. It's the head of out DF. SD out, max out, min out. This all looks fine. Let's see what the dimensions are. Still 421,000, so that's about the right size. It looks fine. I don't know why it's so big, but whatever. Let's compare that to County Flows as 35 megabytes. Are we really 5 times bigger? Maybe. Whatever. It seems to be about working. Let's just check that on Vim. Oops. Vim of summary. And yeah, it seems to basically be working the way we're supposed to. So let me just show you one last time. Clear everything out, read in our data, merge our data, calculate each of those percentages, calculate this unique location for our convenience, and then by county for each of these values, calculate the min-max, standard deviation, all that, and then put it into data frames, which is going to make it easier for us to merge it back together. I guess I'm not technically doing the summary stats. That's why it's bigger than I thought. So we're doing all that data frame stuff, mashing all this together. And then I merged it with DF, which wasn't necessarily the right way to do it. Let's try just saying mean in. Oh, you know what? Let's do pop. There we go. That's a more sensible way to do this. So if we merge this, merge is pretty slow. It's going to take some time. So we're going to merge our pop data with our mean in, and before we move on to the next one, we'll just double check that. But assuming that works, we will then sort of add on each of these other things to this. Oh, you know what? This isn't going to work because pop doesn't have the unique location. So if I take this, let's go ahead and stop this bit of code. If I take this line, I'm just going to put this here. This is a slightly weird place to put it, but that's fine. Oh, whoops, that's not even the thing. Oh wait, that was. There we go. All right, so now we add that unique location to pop. We merge that much faster because it has something to merge into. Instead, before it was just basically making 3,000 copies of that mean in data frame. Now we can merge all this stuff together and it behaves much more nicely. It wrote to summary. Now this is only 733 kilobytes, which is much more sensible. Let's view that file. So we've got this sort of dummy column, 1, 2, 3, and so on. Whatever, we're not going to worry about that. There are ways to make that go away, but we don't need to worry about it today. Unique location, state, county, county name, and we've got our basic values from this. Let's just view out DF in a slightly more legible format. We've got our unique location, we've got our row names, we've got our basic data, and we've got our calculated data. So these are the summary stats that use the other data set, the county flows data set, to calculate all of this stuff. All right, so that was the base R way of doing it. And if you watch the full other video without playing it on double speed, you just watch me struggle through this from memory, and that's just part of the process. If I had been teaching this class a bunch, then I would have this on the top of my head and I would go through it a lot faster, but that would give you the false illusion that it's actually a lot easier to do this stuff than it is. It gets easier, you get fluent, but in practice you run into a problem, you solve it, right? That's really what most of this stuff is, and that involves some back and forth, some fiddling, some experimenting, but we got there. All right, so this was one way to do it, kind of a difficult way to do it, but hopefully this is enough to kind of get you to see how we're doing this so that it'll be more useful when you're doing it for a real project later on. All right, good luck with your attempt at this, and I will talk to you in the future. Actually, I guess before I go, I should say one thing. I did basically do the assignment here. I would recommend, if you're struggling a lot, then copy what I'm doing, but then go back and try and do it with a blank slate. You got the answer here, but that doesn't mean copy my answer. I don't want to see a copy of my answer. I want to see you work through it. Even though we're going to the same place, we should get the same basic stuff. Even if you're just trying to do it from memory, that's going to take you a lot further than just copying verbatim. All right, let me know if you have questions, and I will see you in the future.